All right, greetings everybody. We are in Hanover. We're here with Hany Fouda of Schneider Electric. Welcome.
Pleasure.
We're talking about process and power. Maybe start there. How do this industry interconnect, and since you're in charge of both of them at Schneider?
Absolutely. So welcome everyone, and thanks for joining today in Hannover Messe. Thinking about it 10, 15, 20 years or even 50 years ago, these domains have been always separated. So you have the process engineer sitting in the control room, you have the electrical engineers managing their powertrain, the power capacity they have. Now, what we are trying to do in Schneider Electric is to bring those two domains together in order to drive efficiency into operation, right? Owners, operators are looking for ways to reduce their total cost, and one element that is used heavily in process is energy, right? Because you have to heat, you have to create steam, you have to drive the process with energy supply. In a typical environment, we use design for the maximum capacity we're going to have, and this is not driving the efficiency and the cost structure that we would like to see. So by bringing power and process together, you actually can implement a highly efficient systems, even if it is in brownfield, if it is also in greenfield, from a design to build, operate and maintain, so that you actually have a better functionality that is very much dependent on the process changes that you have that driving the power component as well in your plant operation.
Thank you. That maybe double click a little bit on the value you bring by combining those together. You talk about efficiency. What else?
So once you actually bring these two systems together, you actually are building not only efficiency but a better understanding of how your plant operation really works. So if your feedstock change, which now is very common in a very dynamic, very fluid market that we have today, you are able to actually adapt your operation, your process, and your power in order to manage that feedstock. A simple example, glass, for example. Glass bottling, you use a lot of recycled material, and some of the glass that's coming back from recycled would require more heating in order to produce the new bottles that you would like to use for packaging. So you need more heating, you need more power, and certainly if you don't have good simulation in the system, you will not be able to drive this efficiently. You will pay too much more for your energy that you are consuming.
Got it. And we'll double click on a simulation shortly, but I'm curious if you want to expand a little bit on some of the challenges. Thanks for the use case with the glass heating. Maybe other challenges that your industry experiences with power and the process.
Sure. So one additional challenge that we see, especially here in Europe, aside from the fact that energy costs is certainly relatively high. I mean, it's came down, but there is a certain level of understanding here that in order to increase productivity, which related to the cost structure, you have to drive further efficiency in the operation. So you're not really burning all the energy that you have on the process side, but also providing a level of productivity in order to reduce your costs and increase your competitiveness in the marketplace. Because competitors all around are trying to manage, especially in a low-cost energy geographies. It's very very competitive for them to come and, as we say, eat your lunch here in Europe. So the key is how to manage all these pieces together and really drive a common fundamental by bringing the two domains in tandem together.
Thank you for that. You touched on an important point, the uniqueness of the solution. And let's maybe double click on a solution called EcoStruxure Power and Process. So what is it, and perhaps how is it unique in a marketplace?
Sure. So in Schneider Electric, we're bringing the two domains, as I said, together. So EcoStruxure Power and Process bring not only the hardware connectivity between the EMS system or the energy management system, as well as the process control system, but also bring this up into the software and the simulation. So one aspect of that is I want to train my operators, who are the new generation coming in, who never really experienced the experience or acquired the experience over the last 10, 15, 20 years in operation, on how to run the system flawlessly between the power and process. And for that, I need a simulation tool that would allow me to, if I change the process side, how that impact the power and vice versa.
Right.
So this is one of the simple things that we normally offer as part of the training simulation to help our owner operators really understand and train their new coming workforce to see the interconnectivity between the two systems in the plant. This is one example. Another example is if you have a new, you're designing a new facility, you can actually simulate the facility operation on power and process even before investing in the design itself. So you actually achieve a tremendous reduction in the capex cost, roughly up to 20%. During the plant operation itself, you also reduce downtime because you can simulate basically if anything happened on the power side, how my process will react, and the running costs up to 10% value out of combining the two systems together.
Thank you for that. Now you mentioned simulation. I know a lot of people in the audience may be thinking simulation, digital twins, and this immersive experience. Is digital twin plays a role into this, or?
Yes, so part of the training simulation that we talked about for the workforce is to build a digital twin for the plant, and this is like a pilot. When during a pilot trying to land, for example, they put them on the simulation as part of their regular training, and they do that on a regular basis in order to increase their competencies. This is exactly from a plant operation side. So digital twin is a core for the simulation. The operator, both on the domain of power and process, will be able to really interject and put decisions in the system and see the outcome of these decisions without impacting the plant operation itself. And this is also open a new frontier when you are adopting AI and you want to train the generative AI on your data. The training simulator and the digital twin will allow you to mask this data and help the AI actually to be trained. Because normally what we're struggling with sometimes deploying generative AI is it's easy to train it on internet data, or consumer-oriented data, but it's very hard to find industrial data out of the operation in order to help with the AI training. So digital twin will allow you to get you this foundational data to help with the training of your generative AI.
Hany, thank you, and you've touched on a number of great points there, from energy efficiency to training operators to digital twins and AI, and of course you had some examples earlier from large companies like Duke Energy, but also from smaller companies, which will be displaying the links there. If you folks on the audience have questions for Hany, feel free to leverage the hashtag on the screen, or come and see these examples here in Hanover.
We would love to have you.
And we'll get the questions answered for you, whether online or here at the booth.
Absolutely.